So we're going to work on optimizing specifically rectangular prisms. This is very important if you get into any type of trade, building rooms, houses, any object, anything that is a rectangular prism. We know what type of shape will be the most efficient. We want a cube, right? I know this isn't drawn to scale, but we want a cube. So let's talk about the formulas to find the surface area and the volume of a cube. Now the cube, all of the sides, so I'm going to call this side, they're all going to be what? They're all going to be the exact same length. No matter what I call S, they're all going to be the exact same length, right? So surface area is when we find the area of a face and the area of another face, and in fact we find the area of all the faces and add them together. Well, because this is a cube, what's going to be common with the area of these faces? They're all going to be the same. So instead of finding the area of each individual one, we can just find the face of one of them and do what? Multiply by 6, because there are 6 sides to a cube. So surface area of our cube is equal to, how do I find the area of one of the faces? Base times height. Okay, now the base and the height are the exact same thing. So if I represent it with S, what operation would you use? S squared, right? You're just going to multiply S times S, and we can represent that with S squared. And because there are 6 sides to a cube, we then take that value and multiply it by 6. So the surface area of a cube is equal to 6 times S squared. Okay? Now the volume of a cube. Volume of a cube. How do I find the volume of any rectangular prism? I got to multiply the, what would you call that? Height, maybe. This would be called the base, and this would be called the depth or width, whatever you want to call it, right? But what's common in a cube with all 3 of these? They're all the same. So how can I represent that mathematically? S cubed, because we're going to multiply S times itself 3 times. So we're going to have S cubed as the volume of a cube. Okay? These 2 formulas are going to be very important in order to solve what we're doing. Okay, so the very first one, what they've done is they've given us material, surface area they call it. But imagine we've been given a sheet, and it is 384 inches squared in area. We want to, like we said, maximize our volume here. Okay? So we want to maximize the volume. So let's plug this surface area in. We know surface area of a cube is 6s squared. So our surface area is equal to 384 is equal to 6s squared. Now, excuse me, how many variables are in this question? Just one. We just have s. So because there's only one variable, we can actually go about solving this. The first step what we're going to do is I'm going to divide by my 6. I'm going to move 6 to the other side, and because it's multiplication here, when I move it over, it'll become division. Yeah, I'm going to work backwards, exactly. So we take that 384, we'll divide it by 6, and we get 64. So 64 is now equal to, and remember we move this 6 over, so now we're left with 64 is equal to s squared. Now this squared here, how would I move the squared, or what would be the opposite operation of squared? Square root. Okay, so when we write square root, I know we don't normally write a number along with it, but technically there's a little 2 here. Okay, we don't write it in, it's just assumed when we make that symbol. But the reason I want to show you that is because later we're going to use one that has a different symbol to it. So the square root, in other words, we're looking for 2 numbers, that's why we write the 2 there, that multiply to 64. And what are they? 8. That's right. Now, that means the side of our cube is what? 8 inches in length, right? So we're going to have a cube, rough sketch here, and all of the sides are going to be 8 inches in length. Okay, so that will be our maximized volume with that much surface area. So we've done the first one. Second one, they've given us the volume of our cube. So they're telling you, we need you to take up this much space, do it with as little material as possible. So we want to minimize the surface area. Okay. So same idea, we know our volume formula. We'll put B over here. Our volume formula is S cubed, and we know the volume is 1,331 is equal to S cubed. Now, this is similar to squared. Okay. What would be the opposite operation of cubed? So remember, we called this squared. And what was this operation called? Square root. That first word is very important. Okay? This we call what? Cubed. Okay? What was the second word we used to describe this? Root. So what we'll be looking for is the cubed root. Okay? The cubed root is the same type of symbol, but there is a 3 here. I want you guys all look at your calculators now. Okay? Some of you might have a calculator that has a little X there instead, and that means you're going to have to write the number 3 in first, and then push that X root button to find it on your calculator. Okay? Some of you might actually have that cube root button on your calculator. I want you guys to try it now. My calculator, let's see, nope, that's not what I wanted. When I invert this, here it is. So you guys notice mine says y and then the square root of x. So I'm going to push 1331. Then I'm going to hit this button here. Oh no, actually mine has a 3 there. Okay, so I can just hit this button and it says cube root right here. Let's say you don't have that 3 with a root beside it. So we type in our original number again, 1331. We'll hit this button here. Oh, sorry, I hit the wrong one. 1331. I hit this button. It says y root on mine. I hit the number 3. 3 is representing my cubed root. And I get 11 again. So everybody try that on that calculator. Make sure you know how to do it. And what we just discovered was the sides of this cube will all need to be 11 meters in length. That is a huge cube. Okay? Now that we found how long a side is, we need to solve the surface area for that. And actually, we technically forgot to do the other one.
That's huge.
Yes, it's very large. 11 meters is how long each side of this cube is. Remember, surface area is 6s squared. So now we can plug in 11 for the s. So we get 6 times 11 squared. We do the exponent first. 11 squared is 121. And then 121 times 6 will be 726 meters squared. Is that right, guys? Yeah, that's good. Okay. So that would be the surface area of the cube we're working with.